In this video, we're going to look at this balanced equation, and we're going to work through an example of a limiting reactant type of problem. In this problem, we are given the information that we started with 10 grams of hydrogen and 60 grams of oxygen. And the question is, which substance is the limiting reactant? In other words, which substance runs out first? Which substance gets used up first? Well, we know how much hydrogen is given to us, and we know how much oxygen is given to us. What we need to know is, if we start with 10 grams of hydrogen, how much oxygen do we need? And then we can compare that to how much oxygen was given. So both of these are given to us. So what we're going to do is we're going to start with 10 grams of hydrogen, and we're going to find out, yes, we were given 60 grams of O2, but how much did we really need? Well, in doing the molar mass of H2, there's two H's, and we multiply that by 1.0, that gives us 2.0 grams. So that's 2.0 grams of H2 for every 1 mole of H2. Then the next step is we go to the balanced equation, and there's 2 moles of H2 for every 1 mole of 1 mole of O2. Our last step is the molar mass of the substance we're looking for, which is O2. In O2, there's 2 O's at 16.0 each, so that gives you 32 grams. So that's 32.0 grams of O2 for every 1 mole of O2. It's a friendly reminder that this is the molar mass, so this is always going to be a 1 mole. This is the molar mass, so this will always be 1 mole. The only time these numbers change is here, because you're looking at the coefficients. So when we do this, we get 10 divided by 2 is 5. That's a ratio of 5. And then 5 divided by 2 is a ratio of 2.5. And now we get 2.5 times 32. So 2 times 32 is 64. And then another half of 32 is 16. So we end up with 80 grams of O2. So this is how we interpret this. 10 grams of H2 requires 80 grams of oxygen. But we were only given 60 grams of oxygen. So the 10 grams of O2 needs 80 grams of oxygen, but we were only given 60. So O2 is the limiting reactant. It runs out first. We really need 20 more grams for it to completely react. Therefore, if we were asked how much H2O is produced with 10 grams of H2 and 60 grams of O2, we would have to base the calculation on the 60 grams of O2, because the 60 grams of O2 is our limiting reactant. So now I'm going through the process of calculating how much of the H2O will be produced. 1 mole of O2 on the bottom because of the 1 mole here. 2 moles of H2O on the top because of the 2 moles here. And then 1 mole of H2O and 18 grams of H2O. That's from the periodic table. Each O is worth 16, and then 2 H's give you 2 more. So now I can punch this in on a calculator, and I take this would be a 1 to 16 ratio because 2 on the top to 32. And then the 18 to 16, that doesn't go in evenly. So what I'm going to do is I'm going to take 60. I'm going to divide it by 16. And then I'm going to multiply by 18. And that gives me 67.5. 67.5 grams of H2O will be produced. Why? When I put 10 grams of H2 and 60 grams of O2, the 10 grams of H2 requires 80 grams of O2. So we don't have enough O2 to react with how much H2 we have. 10 grams requires 80, but we're only given 60 grams. That means the O2 is the limiting reactant. It's going to run out first. So now I must base how much we're going to produce of H2O off of my limiting reactant. So I start with 60 grams of O2, and I work my way over to find out how much H2O will be produced. I hope this helps with understanding limiting reactants.